6 parameters only. Okay, but still you can find some of the numbers are insignificant. See, for example, constant is insignificant, and then inflation is insignificant, and consumption first leg is significant, and so on. Right? I can reduce this model further. How? This time I am seeing LGDP minus 1 is insignificant and inflation minus 1 is insignificant. Let me test the restriction on these two so that I can exclude them at once. I will go to test exclusion restriction. I am choosing LGDP minus 1 and inflation minus 1 and putting a restriction on these two simultaneously. What is the result? Oh, I should include the constant as well because it's also turning out to be insignificant. So let me test again by including the constant. Constant, LGDP minus 1, inflation minus 1. This restriction is also valid. This means that I can exclude these three variables on which I have tested restriction. Let me see what happens after this reduction. I am allowed to exclude constant and then LGDP minus 1 and then inflation minus 1. This is my remaining model, and in this model all of the parameters are significant, but there is no R square here. वो कहाँ गया? When you don't have constant in your regression, the R square will not be calculated. I will explain this in details. Now look, here you have only 3 parameters. From the initial model that you have started with, you are having 9 parameters. And R square is an indication of what is the explanatory power, but in the last model we don't have R square. There is another indication of the explanatory power, which is sigma. Sigma is the prediction error. What is prediction error in the model where we have 9 parameters? What is value of sigma? 0.10, right? You have reduced this model, 3 parameters in the initial stage, then 3 parameters again. Now what is value of sigma? 0.010. So you have reduced 6 parameters out of 9 without paying any cost in terms of explanatory power. Still you have same predictability, right? And you can also test the assumptions of the model. Let me see, test summary. All these things are also okay. Yes. Achha. What you are talking about is ARDL co-integration. We will go to it in a short while. This is just ARDL model. There is one thing which is called ARDL cointegration. What you are talking about is ARDL cointegration, and we will go into the details of that. Right? Now your model is reduced from 9 parameters to 3 parameters only, and without any loss of predictability. Look, now what this model is telling me about the consumption behavior. The consumption is depending on past consumption. This is what is called habit persistence. The consumption is dependent on your current GDP, current income, plus past consumption, habit. So this model is consistent with the habit persistence model, right? In addition to that, the inflation is also playing a role to determine the current value of income. Current value of consumption. Is it okay? I will discuss this in details. Right? Okay, so this is how you can reduce the size of model, and this model will give you a parsimonious model to explain the behavior. This is now consistent with theory. When I started making model, I was having no theoretical interpretation of the coefficients, but now I have one leg term of consumption, and I know what is the theoretical interpretation of this. This is matching with the habit persistence theory. And then I have GDP. I also know what is interpretation of this. If income is going up, the consumption is also going up. I know the interpretation. Inflation is also playing a role. So out of a theoretic model, out of a model which was not based on theory, we have come up with a model which is matching with some kind of theory. Yes.
So in this one now, in terms of policy recommendation, what will you take instead of having the optimistic way of sending the policy recommendation?
What is the recommendation for government?
Yeah, in terms of this.
See, actually, this model is having less utility in terms of policy recommendations. Basically, there are policy recommendations in this as well, but it's not like what you see in the interest rate and inflation relationship. You can advise how much interest rate you should increase or decrease in order to control the value of inflation. This is not like this. Basically, what happens from this model, you can calculate the elasticity of consumption with respect to income, and you can calculate the MPC, right? What is the utility of MPC? You know, the increase or decrease in the value of government consumption is having multiplier effect, and the multiplier can be calculated out of this thing. These are the log terms. These are not directly the MPC. You have to calculate MPC out of this, but at the end you will be able to tell what is the consumption multiplier in this case, what is the government spending multiplier in this case. So if the government is reducing its consumption by 1 billion, how much will be the effect on economy, you can predict on the basis of this. Right? And there is one more thing which can be calculated out of this model, and that is called static Lagrange solution. The Mubinsa was asking about Lagrange relationship. The Lagrange relationship can be calculated now out of this model. How? Basically what you can do is to go to test and then dynamic analysis and then static Lagrange solution. This is your static Lagrange relationship between GDP and inflation and consumption. What this is telling you, basically the equation is written in the bottom. L cons equal to 0.98 times LGDP plus 0.02 time inflation. Is there any other question?
So normally can consider the sigma instead of the R square.
Instead,
Because like you said because of the exclusion of the constant term, so there will the R square will
yes.
disappear. So that's why I'm saying what we use to know how the model is explained
How much the model is explaining?
in terms of when you have a high R square, you know that the model is 99% explained and then 1%
See, even if you are finding the R square in a time series model, I have said it is meaningless. This was a meaningless number which is removed from the model. There is no big loss. What you can